In this video, I'll poorly explain the notion of blowing up in geometry. Now, because this notion in general is pretty rigorous and abstract, which has no place here, I'll be actually poorly explaining blowing up a point on a plane. Wait, no, I didn't mean that. So now that I'm in federal prison, let's get to it. First, we gotta talk about curves. We can say a curve is something that goes around the plane. No, this plane. Some of y'all might actually be familiar with some curves like this, or this. Or if you're real fancy, you might have seen the Jesus fish looking like this. But there's something bad about all these curves. Do you think you can find it? Yeah, you're right. They're all not differentiable at the origin. If you haven't taken calculus yet, or just forgot, let's look at an example of the Jesus fish. Imagine we have a skateboarder riding the slopes because of these curves. When they get to this point, the skateboarder starts having an existential crisis as they do not know which direction the board should go to appease the gnarly skateboarding gods. That aside, if you're like me and in math hell, we really want to fix these bad points while not fucking up the other parts. It turns out it's actually possible to do this, called blowing up. The key here is to realize that when the skateboarder gets to these bad points, there's no correct direction to go, so instead of carefully choosing the pros and cons of each choice, we're just going to separate these lines by their slope. Remember way back when we learned that the slope of a line controls the slope, or how steep or shallow the lines are? And if we squint our eyes enough, we can see that the only things differentiating these lines is their slope. Better yet, any point on a line is uniquely determined by its slope and a single value. For example, on this line y equals 2x, if we want to know what this point, say, this is, all we have to know is either the y value or the x value to recover the other. So if we have a graph of a bunch of lines like this, we can see that the origin is a bad point. So we can separate out these lines on a new plane where the vertical axis represents their slope. This is really nice as we can keep track of any non-zero point by realizing the y value is just the x value times its slope. And the bad origin point blew up to be the entire vertical axis. So going back to the Jesus fish, instead of graphing the curve like normies, we realize that if we zoom up near the origin, it looks like two lines with slope 1 and minus 1 intersecting. So we can just blow up the origin like before. Doing so, we get this. And we can see that the picture makes sense as the two different slopes at the origin were plus or minus 1, and the new curve intersects the vertical axis at plus or minus 1. Isn't it cool when math just works out? A better picture in my opinion is this, which really shows up the blowing up aspect. Now obviously this is a very simplified explanation as this, but yeah, blowing up is really nice because now we have this curve where it's smooth and differentiable everywhere, and it preserves all the information that we had on our original curve, except we just need to keep track of the vertical axis that corresponds to our bad point. So yeah, that's it. But if you ever want to learn more about this, just read Hartshorn or watch Richard Borchard's. Just don't talk about this at the airport. Okay, bye.